Today's lesson is on rational exponents. Rational exponents. A rational exponent is just, it's an exponent that is rational, of course. That is it's a fraction, okay? So it's a fraction. That's what you're going to look at it and say, oh, that's a fraction. Math people, they look at it and say, oh, a rational exponent. Okay, and then here's the real deal. So here is the definition, or the book's definition of actually how it works. And I want you to see this. So if P and Q are integers, and I'll explain it when we're done writing, are integers with Q being greater than 0 and B is a positive real number, then, okay, pause the video, get all that written down so that I can explain it to you. Okay, so go ahead and pause real quick. Okay, so if P and Q are integers with Q greater than 0 and B is a positive real number, then this is what's true. B to the PQ, there's my rational exponent, equals the Q root, so there's the Q, of B raised to the P power. You can write it that way, that's the way we use it a lot of times. It also is the same as B to the Q root with the P inside under the radical sign. So either way, they both work. We use it this way a whole lot, okay? So, so this is definitely one of the important things to know, especially when you're simplifying the radicals. So let's look at an example so you know what the heck I'm talking about. Okay, so here's an example of what you would do. So I have 16 to the 3/4. 16 to the 3/4. Well, if you look here, the Q, or the denominator, right, of that fraction, the denominator goes into the V of the radical sign. So if you think of it like this, D, denominator, rhymes with V of the radical sign, you'll know exactly where to put them. That's the hardest part of all this. Where does it go? I don't know. You know what? They rhyme. D and V. That's where they go. Then the numerator is just, you know, the guy that's left. You can put them out here, you can put them in here. Most of the time that works better, and I'll show you. So 16 to the 3/4, I'm going in this direction, would be the 4th root, because the denominator goes in the V of the radical sign. So the 4th root is 16, all raised to the 3rd power. Well, you know the 4th root of 16 because we've been working with these, and the 4th root of 16 is, yeah, 2. Okay, so then that's going to give me 2 cubed, or 8. So in the end I have 8. Well, let's write down the steps that we used. So the first thing we did was we rewrite as a radical. And then for this simple problem, the second thing we did was we simplified the radical. And those were our steps. Here was our problem. The first thing I did was rewrite as a radical. I copied this, rewrote it as a radical. I remembered that the D and the B, they rhyme. And then I simplified the radical. So here's the thing I want you to remember. I want you to remember this. Here's some eyeballs. I don't know why I use eyeballs for remembering, but I do. Okay, I can get it better red pen. There we go. So this is just, usually my eyeballs just mean, you know, something to watch out for here. Okay, something to remember. So remember this, the denominator of the exponent the denominator of the exponent goes into the b of the radical sign. They rhyme. R-H-Y-M-E, I think. D and B. Okay, they rhyme. D and B. Okay, and this is only when you have a fraction. Not true if you had 4 over 1, then that doesn't make any sense, right? Okay, so it's only true with a rational exponent. The denominator of the exponent goes into the b of the radical sign. They rhyme, D and B. All right, get these notes down. I'm going to erase. Okay, well there's a lot to this little part, this little first piece of this chapter. It's all stuff you have to get down and have figured out. If you can do this, it's really going to help you the rest of the time. Okay, so we're going to keep looking at some examples. Of course, I'm going to give you some different ones and different situations so we get it all figured out. So here's an example. Here's another example. I'm going to show you some more examples, the different situations, and this very first one is just another like we did in the beginning, so just another example, just to make sure you've got it. Okay, you're going to go ahead and you can stop the video and work this problem, see if you get it, and then start it up again, and I will show you how it goes. So go ahead, I'll let you pause. Alright, how'd you do? Let's check your work. So I have the 2 is in the denominator, it goes into the b. Here's my base, it's 81, and I'm going to raise it to the 3rd power. The square root of 81 is 9, so I have 9 cubed. And 9 cubed, I get out my handy dandy calculator because that's going to be a pretty big number. And I'm going to get 729. Okay, 729. Now you always have to go ahead, whenever you have a number to an exponent that you can simplify, you have to simplify it, right? The only ones you get to leave are anything with a variable. But if you have a number, you got to take it all the way and simplify it completely. Okay, now this example, okay, phone rang, I had to run. Okay, so a negative exponent, so let's go 8 to the negative 5/3. 8 to the negative 5/3. Well, I'm going to do the same thing. I'm going to change it over to radical form. There's my base, that's my big number. I know the denominator goes in the b, because d and b rhyme, and I'm going to take it to the negative 5th. So you're going to simplify what's in there. The cube root of 8 is 2. So what I end up with is 2 to the negative 5th. And we already know how to do negative exponents. We know it's like a crying baby. We have to drop it down. So it's 1 over 2 to the 5th, or 1 over 32. Okay, so negative exponent. Same steps. Okay, same steps. I just wanted to prove to you that it all works. So same steps as last time. Here's another example. There's so many different ways you can do these. So, or not different ways you can do them. Actually, it's all the same way that you do each and every one of them. It's just different variations of the problem. So there's a lot of different variations. So here's another example. And this one is with a decimal. Okay, so if I have a 9 to the 1.5, well, 9 to the 1.5, I don't know how to change that to radical form, but I do know how to change 1.5 to a fraction. And I know that 1.5 is, what is it? How do you do it? Oh yeah, it's 15 over 10, right? That gets rid of my decimal. And I can change that to 9 to the 5 goes into 15 3 times and into 10 twice. So it's 9 to the 3 halves. So you're just going to change. So number 1 here for a decimal is changed to a fraction. Okay, and then it's all the same. So from there, then you're going to do the same thing. You know, write as a radical, and 3 is simplified to the radical. Okay, so simplify. So now what I have is the square root, where's my 2, of 9 cubed. Well, the square root of 9 is 3, and then 3 cubed is, we would get 3 cubed, and 3 cubed is 27. Okay, so 3 different things for you there. 3 different examples. Okay, this one had the negative exponent, this one had a decimal, this one had a positive exponent. So go ahead and get those notes, write those down, and we'll move on. Okay, if you start with a radical, change to a rational exponent. Okay, you have to change to a rational exponent to be able to work with these numbers. So when they're in radical form, it's a lot more difficult, actually, it's a lot more difficult, if not impossible, to work with them. So you have to change over to a rational exponent. So if you start with the radical, change to a rational exponent. And here's an example of this. Here's an example. I have 1 over cube root 81 all to the negative 3/4. Well, I have this combination of rational exponents and radicals. Well, I don't want a combination of the two. I really need them to all be rational. So I'm going to look at this guy, and I'm going to change it over to a, sorry, I lost my train of thought. I'm going to change it over to a rational exponent. Okay, so to change this, I'm going to say it's 81, so just looking at this little piece, it's 81 to the 1/3, right, on the bottom, 81 to the 1/3, but it's on the bottom, right, and I'm going to write it as using negative exponents also. So that means I'm going to rewrite it as 81 to to the negative 1/3. Okay, 81 to the negative 1/3. So this is 81 to the 1/3, but it's in the denominator. I need to move it up to the numerator, so I have to go to a negative exponent. And then it's all raised to the negative 3/4. When we go from a power to another power, you know that you multiply. So what I end up with is 81 to the negative 1/3 times negative 3/4. Well, a negative times negative is positive. My 3's cancel out, and I end up with 81 to the 1/4, or the 4th root, right? Because the denominator goes in the b of my radical sign, the 4th root of 81. And the 4th root of 81 is 3. So I get 3. Okay, so what I'm doing here is I am, number 1, rewrite all radicals as rational exponents. Okay, and you might have to use negatives because you want them all into the numerator there. So that's the first thing you're going to do. Okay, so rewrite, and then you're just dealing with laws of exponents like we did here. Okay, multiplying, you're going to have to use your fractional skills there in that skill set, and you'll see that they're going to change here in a minute. You're actually going to have to be able to find a common denominator and add them together. Yes, that's coming up. Okay, so this is an example. Let's say this is an example with a radical. Okay, with a radical. So I started with the radical. And what do I do with it? Okay, there's two forms. There's an exponential form that would look like this. 2 to the 3/2. And then there's a radical form that would look like this. This one could actually look like this, which means I can simplify this. So you want simplest radical form. So simplest radical form means that you have to simplify it. Okay, so I have 3 2's. I need 2 to get 1 out. So I'm going to be able to bring 1 out, and then I have square root of 2. So that's simplest radical form. So 2 different forms that you have to know. And you have to show them in one of these forms. Okay. The bases must match. So if I have two things like this, I have the square root of 1/3 times the cube root of 9. Well, those base numbers don't match, okay? What I will have here is, and this is what I'm going to do, is I'm going to first make it so the bases match. So number 1, match bases. And what you're going to have to do is you are going to have to look at these numbers and say, okay, well 3, that's the lowest, it's prime. I can't do anything with it. But 9 isn't prime. 9 could be rewritten as 3 squared. So in my little thought bubble here, I'm thinking, 9 is 3 squared, and then the base would match. So I'm going to go ahead and say, all right, square root 1/3 times the cube root of 3 squared. Now I'm going to write it as a rational exponent. So 3 is going to be, or the square root of 1/3 is 1 over square root 3, and the square root of 3 is 1 over 3 to the 1/2. It's on the bottom. I don't want it in the denominator. I actually want it in the numerator, so I'm going to have to go to a negative exponent. So what I would have then is 3 to the negative 1/2. Over here, I'm going to switch it over to rational exponents. So I have 3 to the, remember the denominator is in the b, so to the 2/3. Now I'm just going to use law of exponents to go ahead and combine them. So I'm multiplying the bases, but I don't really multiply the bases. I actually add the exponents. So what I would have then is 3 to the negative 1/2 plus 2/3. And then you're going to have to, common denominator. So I need a common denominator. It looks like it's going to be 6. So negative 3/6 plus 4/6. And I'm going to end up with 3 to the, 1/6. That is in exponential form. Sometimes, though, they want it in simplest radical form. Okay, so it could be this, it could be the 6th root of 3. Okay, one of those two. So this is exponential form, this is simplest radical form, depending on what they're asking you for. So let's look at the steps for this. So the first step was match bases. The second step is to write each piece, well, let's say that, write each term in exponential form. So that's with exponents. All right, and then number 3 is use laws of exponents, which we already know, to simplify. Okay, use laws of exponents to simplify. All right, if you need to get the rest of those notes, go ahead and pause the video, write them down, and we will go from there. Okay, here's the next thing. We're going to write the cube root of 9 times cube root of 3 in exponential form and simplest radical form. Okay, so in exponential form and simplest radical form. So it's exactly what we just did. Here's my example. Let's put it down here. So example. So what I have then is cube root 9 times cube root 3. And what I told you in the last little piece was the first thing you need to do is match bases, because the bases don't match. I'm going to try to match to the 3 because I can't match it to, I could match it to the 9, but I'm going to try to match it to the 3. So what I'm going to do is I have cube root of 3 squared times square root of 3. Okay, I matched the bases. That was step 1. Step 2 is to write it as a rational exponent or in exponential form. So I have 3 to the 2/3. Remember, the denominator is in the b of the radical sign, times 3 to the denominator is in the b, but there's nothing there. You know it's a 2. That's one of the ones we don't show. So I have 3 to the 2/3 times 3 to the 1/2. From there, we're just going to use laws of exponents. So I'm multiplying bases, but I don't really multiply the bases at all. I just add the exponents. So I have 3 to the 2/3 plus 1/2. I'm trying to add two fractions that don't have a common denominator. So I'm going to have to find a common denominator here. It looks like 6. 3 goes into 6 twice, times 2 is 4. 2 goes into 6 3 times 1 is 3. And my answer here is going to be 3 to the 7/6. They wanted it written in exponential form, and that is exponential form. Okay, so this is exponential form. They also wanted it in simplest radical form, so I need to put it in simplest radical form. So I am going to write that down because these can be a little tricky. It's not just saying radical form, it's saying simplest radical form. So I can write it in radical form. It's not going to be simplified yet, I'll simplify in a sec. So I know my base is 3, I know the denominator is going to be 6, and I know I have that 7 next to the 3. So I have 7 3's, I need 6 to get 1 out. So this is not simplest radical form. Simplest radical form is going to be the 3 I can take out and the 6th root of the 3 that I'm going to leave in there. This right here is simplest radical form. That isn't simplified. Okay, so we had our steps. Our steps were match bases. Our second was write in exponential form. Number 3 was use laws of exponents. 4 was simplify. And write in both forms. Okay, that's all you have to do for those. Okay, so we have exponential form, that's with the exponent, and we have simplest radical form, that's with the radical, but it has to be simplified. All right, pause the video, finish up your notes. Okay, the next one is solve for a variable. And so we need to find a solution. And you're going to have to put it in set brackets. Okay. So we're going to solve for a variable. Okay, solve for a variable, which means I'm going to have to find a solution. So before we were just simplifying, but now we're going to have an equal sign in we're going to have an equation, so it's going to have an equal sign in it. And we're actually going to have to decide or solve for a value of our variable. So here's an example of what I'm talking about. And they look a little scary at first, but you will see that these are not that difficult. Okay, so just stay with me here. So here's an example. And the very first thing you need to do is realize that x needs to be by itself, completely by itself. Nothing multiplied to it, nothing divided by it either. It can't have anything added to it or anything subtracted from it. Okay, it has to be alone, completely alone. So number 1 is get variable alone. And I mean completely alone. So what you would do is you're going to take that 6 and you're going to need to get rid of it. or divide it out, right? Okay, so once I do that, I get x to the 2/3 equals 9. I want it to look like this when I'm ready to really simplify this thing. So I have x completely alone. There's nothing multiplied to it, nothing divided from it, nothing added to it, nothing subtracted to it. It's just x to some power, okay, to some power. So this one's to the 2/3 power. Okay, when I need x to the first power, right? When I solve for x, it's always x to the first, or whatever your variable is, to the first power. But I have to the 2/3 power. So how do I get it to the first power? Well, if you think about laws of exponents, you take laws of exponents combined with the idea of a reciprocal, right? A reciprocal, 2/3, the reciprocal of 2/3 is 3/2, because when I multiply them together I get 1, I get a positive 1, right? So it carries its sign. All right, so what we're going to do then, knowing these two things, is we're going to go ahead and raise this to the 3/2 power. Now, you see that these are reciprocals, so I'm raising it to the reciprocal power. Why did I do that? Well, because the definition of reciprocal is when you multiply them together you get 1, a positive 1, and that's what I want. I want x to the first power, so 1 power. What I do to one side, I have to do to the other side. So I'm going to go ahead and raise both sides to the 3/2 power. What I end up with then is x to the 2/3 times 3/2. But you know that 2/3 times 3/2, because I've said it 3 times now, that's just going to give you 1, or just x, right? Okay, so your second step, number 2 here, is raised to the reciprocal power. And that's both sides. Both sides. Okay, so both sides of that equal sign will be raised to the reciprocal power. And then the next thing I'm going to do is I'm going to change this 9 to the 3/2 into a radical and see if I can simplify it. So here we go. Remember, the denominator goes in the d of my radical sign, d, v, they rhyme. So the d is part of the b here. And then I have 9. And then I'm just going to take that numerator and put it right out here on the outside. That's usually the way it works best. Usually the way it works best, not always. Usually. Okay, square root of 9 is 3. So what I have is 3 to the 3rd power. So x then must equal 27. Okay, x equals 27. And you can put it back in there and you can check and make sure that 27 is my solution set. Okay. Let's write down the rest of my steps. Get variable alone, raise to the reciprocal power, both sides. Number 3, change to radical form. And 4, simplify. Okay, so that is what you have. There are your rules. Let's look at one with a negative exponent, and I'll show you that it's not that scary either. So here's one with a negative exponent. I have 5x to the negative 3/2 equals 40. Okay, same exact steps. We don't need to write anything more for our steps. So my first step is get the variable alone. Nothing multiplied to it, nothing divided from it. So I'm going to divide both sides by 5. What I end up with is x to the negative 3/2 equals 8. Next step, raise both sides to the reciprocal power. So negative 2/3, negative 2/3. This right here, when I go from a power to another power, what I end up with is x to the negative 3/2 times negative 2/3. But all of that just goes to 1 because I multiplied by a reciprocal. So that's just going to go to 1. And here, then I have 8 to the negative 2/3. Okay, I have x just to the first, because we just showed that, it goes x to the first. I need to write this in radical form. So I'm going to write it in radical form. I'm going to take the cube root of 8. Remember, the denominator goes in the v, the d and the b rhyme, they go together. And I'm going to then raise it to the negative 2nd power. So even though it's a negative exponent, the only thing you really have to remember is that when you multiply to get x to the first power, you have to carry that sign. So if it's a negative exponent, you're going to do a negative reciprocal. And then when you write it in radical form, remember that negative number just goes on the outside here. And then all you have is x equals 2 to the negative 2nd. Well, you have a crying baby, so you got to put it down. So x equals 1 over 2 squared, or it equals 1/4. And my solution is 1/4. Okay. Pause video, take the rest of the notes if you need to. I have 2 more examples for you, and then I'm finally finished. Here's the new one. T minus 4 to the 2/5 minus 3 equals 1. I didn't erase any of the steps because the steps are the same. You need to get the variable alone. Well, the variable is in here, right? So when I say you need to get the variable alone, you need to get this quantity alone. Anything that's raised to the power, okay? Anything that's raised to the power, this is what needs to be alone. You're not going to be able to get t completely by itself right now. Just think of this as one big variable here, this t minus 4. I do have to get rid of this 3, so I can't have that hanging on it because it's not part of what is being raised to the 2/5 power. So I'm going to get rid of that by adding 3 to both sides. What I end up with is t minus 4 to the 2/5 equals 4. Okay, so t minus 4 to the 2/5 equals 4. I need to raise everything now because all of this stuff is being raised to the 2/5. So I'm going to raise everything then to the reciprocal power, which would be to the 5/2. What I do to one side, I have to do to the other. Okay, to the 5/2. Now this, right here, this all goes to 1. And now what I have is t minus 4 to the first power, or I just have t minus 4. Now I have 4 to the 5/2. I'm going to write that in radical form. Remember, the denominator goes in the b of the radical sign. D and b, they rhyme. Here's my base, there's my 4, and then that numerator can just go on the outside. What I have then is t minus 4 equals the square root of 4, which is 2, to the 5th power. Or I have t minus 4 equals 32, because that would be to the 5th power, and I can just go ahead and finish my solution. I'm going to add 4 to both sides, and I have t equals 36. And 36 is my solution. Okay? Might want to go back and check and make sure, put it in there and throw it in here and see if it actually works. That's always a super good idea. Okay, we're almost there. Here's your next one. Okay, this is the last one, thank goodness. I'm going to give it to a negative power. Now that's just the negative second power. So wasn't I talking about fractional exponents? Well, not necessarily. In negative 2, I could do negative 2 over 1, right? It has a reciprocal just like anything else. So what I'm going to do here is I'm going to go ahead and I'm going to raise it. Let's see. Let's do this. That 1/4 is kind of bothersome. And I know that it would be easier if I wrote it another way. And I know we've talked about this a lot. If you look at that 4 is really 2 squared, 1 over 2 squared. But if I want to write it as a negative exponent, I have x minus 3 to the negative second equals 2 to the negative second. Okay? And if you don't quite see where to go from here, you can raise it to the reciprocal power. And the reciprocal power, it's negative 2 over 1. So my reciprocal is negative 1 over 2. So negative 1/2. Negative 1/2. Okay, raised to the reciprocal power. This is going to go to 1. But what's this going to do? Well, you know what? That one just so happened to go to 1 also. So what I have then is x minus 3 equals 2. I'm going to add 3 to both sides, and I get x equals 5. And I could put it in there and check it. 5 minus 3 is 2. 2 to the negative second is 1/4, which equals 1/4. That's what I was looking for, right? So that is my solution. Right there. Okay. That's it. Good luck. We'll work on this in class.